Welcome back. It's nice to see you all again. As a quick update, I did a quick repair of the auto grader this morning, and I think I was able to fix the error that caused some of you to get bad reports. So I'm going to check that over after class today and push your new grades and reports if indeed I fixed it, but I have to check it over first to make sure. Sorry, let me turn off all the notifications on my screen. Okay. There we go. Okay. Any questions about that? Yeah. Okay. Sorry again for the confusion and stress. Okay. So today we'll be starting our explorations of the Module 3 material. As I mentioned on Monday, now that we have the basics behind us, the structure of these course meetings is going to be transitioning starting today to a little bit more of a hands-on style of learning. So before we continue with that, does anyone have any questions or anything else you'd like to raise about any of the material or assignments so far in the course that you'd like us to make sure to get to? No one. Oh, Jane, did you have something? I see you're unmuted. Nope, you're muted now. Wonderful. Okay. So in Module 3, if you've started to go through that material, then you've started to learn about some more sophisticated programming styles and some more interesting algorithms for solving problems like sorting. You've also started to learn about some classic data structures, which you can think of kind of like tried and true approaches to organizing and manipulating data efficiently. So what I thought that we could do today is practice writing code for sorting a linked list. So that'll tie together some of the concepts you learned about. So before we start coding, let's start off all together by making sure we understand the basic quicksort algorithm, and we'll also define a class for linked lists that we can use to solve this. And then we'll break out into groups, and then you'll try putting everything together. And then after you've made your attempts, then we'll meet back as a class and discuss. Okay. So does anyone happen to remember the quicksort algorithm? I guess any of the sorting algorithms would be okay, but quicksort's kind of an interesting one. Did anyone start Module 3 yet? No. Yes.
Just a little bit.
Okay. Does anyone, okay, well, what is sorting first of all? Does anyone know what sorting means? Like if you have something,
ordering
sort it.
elements in a list.
Yeah, and what does that mean specifically? Like, what do you mean?
From smallest to largest, for example.
Yeah, wonderful, great. Yeah, so if you have a bunch of numbers that are in a unsorted order or like a non-monotonically increasing order, then sorting means you get a new set of numbers that is in monotonically increasing order. Okay. How, if you were to write a function to sort a list, like how would you approach that? Like, can you think of any, whether you have or haven't kind of looked over some example sorting algorithms, like, how might you approach that problem, or what do you think would be involved? What are your thoughts, even if it's just like a random brainstorm?
You could do like an if statement and use an append command to like order them from smallest to largest. So like, I don't know, for I in whatever, and then if X is greater than I, append to a new list.
So I is like the current item, and then X is another item you're comparing it to, or
Yeah.
what are you thinking of that? Okay. So something like, okay, so you're thinking of like going through the list and maybe keeping track of, yeah, so you could imagine like going through the entire list and then getting like the minimum value item, and then going through the list again. And then once you get to that item, you remove it and append it to some other list. And now you like go through the list again, compute the minimum item, and then append that to the new list, remove it, and then keep doing that. So you're kind of like going through the list many, many times and then gradually building up like by the minimum item. Okay, so that would result in a sorted list. Yeah, so that's a great idea. It's a little inefficient because you're going through the list many, many times. So basically you have to go through the list one time for each new item you add to the sorted list. But I think that, will get you a sorted list. So that's good. What else could you do?
You can use median or average to sort things like if it's smaller than average or median, you put it on the left side, or if it's bigger than that, put it on the right side. I think you can use that process to, in the PC.
Cool, yeah. So that's actually kind of similar to the quicksort algorithm. So you kind of, yeah, so you pick some number, let's say the median or the average value. So computing that would require looping through the entire list and maybe computing the sum of all the elements and the number of elements. And then if you wanted to compute the average, you just divide by the number of elements. So that would get you the average. And then you could go through the list again and say, is each element in turn bigger than or smaller than the average element? If it's bigger than the element, you'd put it on one side. And if it's smaller than the average, then you put it on the other side. And then now you have two lists that are broken down by whether they're bigger or smaller than the average. And you could kind of recursively do the same thing to each of those smaller lists. And then at the end, you have to put everything together. So you have like the sorted version of the smaller items plus the middle item, and then the sorted version of the bigger items. So if you did that recursively, I mean, that's actually the quicksort algorithm or something very close to it. Yeah, is it clear why or how that works to everyone, or any questions on that? Okay. The like general implementation of quicksort is instead of doing that first loop through to compute the average item, in practice, often you just select an item at random and use that as what's called the pivot element, which is like the thing you're comparing everything to. Another kind of classic sorting, I mean, there are a whole bunch of classic sorting algorithms, but not like the other algorithm people often first learn about when learning about sorting is called bubble sort. And it's kind of a fun one. So you have every element on the list, and then you start with the first element and look at its neighbor. And if they're in the proper order, then you move on. Otherwise, you switch their values, and then you move on to the next element and say, is the second one and the third one correctly ordered? If so, you move on. Otherwise, you switch them. And now is the like third and the fourth item correctly ordered, et cetera. And then you go through the list. But then you have to go through the list number of elements times to make sure that in the worst case, if you start with a list that's like sorted in reverse order, because each item can only move by one position, forward or backwards each time. So in the worst case, if you pass in a reverse sorted list, then bubble sort will require you to run through like n-1 times to get the first element all the way to the end. So it's similarly inefficient to the technique that Rachel you suggested, but it does allow you to. Whereas your approach, well, no, actually, yeah, similarly inefficient in terms of like time and memory usage, but yeah, but it'll work. But you can kind of picture like bubbles rising up in some liquid. It's sometimes intuitive. Okay, so the let me share my screen. Okay. So the official quicksort algorithm, actually, maybe I'll write some text instead of, oops. Okay, so first of all, if the sequence is empty, return it. And then select an item at random. This is the pivot element. And then we could say its value is n. And then create two new sequences, A and B, where all of the elements in A are, oops, oh gosh, less than or equal to n. Good Lord, I'm not typing this well this morning. And all of the elements in B are greater than n. Okay. Okay. And then now recursively quicksort A and B using steps 1 through 4. And then return A concatenated with B. Okay. Okay, what does concatenated mean? Does anyone know? It's kind of a strange word.
Tagged onto the end of.
Oh gosh. That was cool. Jordan, do you want to enter or not enter?
I was
Unmute
just gonna
yourself.
say, when you like glue two things together, if that makes sense.
Yeah. You glue two things together. That's a great way to think about it. Yeah, so A concatenated with B means you like glue B onto the end of A. So now they used to be two lists and now they're one super list containing all the elements of both. We have everything in A, and then you stop, and then the next element is the first element of B, and then all the elements of B. Okay. So does this quicksort algorithm I've written here make sense? And do you have a sense of how you might turn that into Python code?
Sorry, I have a quick clarification question. So how is concatenation is, how different is concatenation to appending?
So so concatenation is the like verb for what well, it's actually the extend operator in, or the extend method in Python does. So let's say we have A is the list 5, 4, 3, 2, 1, and B is the list, I don't know, 10, 9, 8, 7. Then connect there. If we did A dot extend B, then that would concatenate all the elements of B to the, sorry, what did I just do there? That would concatenate B onto the end of A. So it would concatenate A and B together. And now this is a like destructive operation, if you will, in that it changes the value of A. So now the value of like the last item of A, instead of pointing to like the end bracket, it now points to the first item of B, but B is unchanged. Oops. Okay. All right. And then you can do a similar thing with strings. So hello world will concatenate the strings hello and comma space world exclamation point into a single string hello comma space world exclamation point, all one word, or all one string, 2 words, 1 string. Okay. All right. Any other questions? I mean, so the other confusing thing, maybe it's not confusing, but sometimes like we haven't encountered this concept before. Recursion was one of the new concepts that was brought up in module 3. So it's like, you have some function and then it's got arguments, and then somewhere inside the function, you're calling my function with some new arguments, and then you're returning something. So recursion means that it's like the bad way to define something in like English, for example. It'd be like you're using a word in its own definition. So like, yeah, if you're like, what does the word cold mean? And you're like, it's like when something is cold, like that doesn't give you additional information. Similar, like, and say it's kind of a weird way to define things in spoken or written or human friendly languages. But in computer code, it can be okay. It just means that, like, the key is that, if you have some argument here, you don't want to pass the same argument into the function when you call it inside of itself. You might say like n-1 instead. So it's like, okay. Wow, a lot of confused looks. Do you want me to go through a simple example of recursion, or yes? Okay. Okay. A classic example of recursion is something like factorial. What does factorial do? Like, how do I compute it? Just like from a conceptual point of view, if I said like 3 factorial, what am I referring to? Like, what does that mean?
Isn't it like 3 times 2 times 1?
Yeah, exactly. 3 times 2 times 1. So it's like if you have factorial, you multiply the integers, well, 1 through n, where n is that number. You just multiply them all together. Okay. And then we could define special cases like factorial of 0. We could, define that in some special way, or we could just say we're not going to deal with that case. So, and then if like n is 1, then we already know the answer. Like factorial is just 1, of 1 is just 1. And then otherwise, then we'd return factorial of n minus 1 times n. And then we could also have a special case, like if n less than 1, return, or just like, we could just say it raises an exception. Okay. Great. Okay. And then we could say like, okay. Huh. Oh, you have to actually return it. Okay. Was that clear why that gave an error? So if I don't include this return statement, then what it's doing is return none, which isn't actually what we wanted. Okay, so that gives us 6, 3 times 2, and then it's happy to chunk through whatever we give it. Oh, or within reason. Okay, that's a really big number. Factorial of 1,000 is quite a big number. Okay. All right, I'll believe that the computer was unhappy with that. Okay, so 5 times 4 is 20, times 3 is 60, times 2 is 120, so that works. Okay. Does that make sense? So we've defined this recursively because factorial is called within its own definition. Python is totally happy with that. So similarly, if we had like quicksort of some list, then somewhere in the function definition, we're going to have like return, and then some way of concatenating quicksort A, quicksort B.
Will you explain why here you use concatenate as the command and earlier on line 2 you used extend to like get the two lists together?
Yeah, so what I'd like you to do in the exercise when you, in your breakout groups is, so this works for lists, but I want you to try also learning about data, like this data structure, linked list, which is like a slightly more complicated version of that acts similar to lists. And so you're going to have to write your own, or we'll maybe write it as a class, but we'll write our own linked list object, but it won't have this, it won't necessarily have this extend method in it. I guess you could write an extend method for the linked list class, and then that'd be totally fine. Then you could do a.extend or quicksort a.extend quicksort b if you want. Okay. Okay. Any questions on quicksort? Any other questions? Okay. And did recursion make sense? Okay, cool. Okay. Next, let's define a linked list class. So a class of object that will, that will be able to use like a linked list. Okay, so first of all, well, we'll have to remember what a linked list is or discuss what a linked list is, which we don't know that yet. But even before we know what a linked list is, how do you define a new class? Like, what do I type? Who wants to help me out?
And you just type define class and then name the class.
Oops. Like this.
I think just class, right?
Yeah. And then what goes here? Do I put parentheses, no parentheses, colon, semicolon, 52 asterisks arranged into an artwork?
I think a colon, right? Or maybe some parentheses in there. Maybe just a colon.
You can put parentheses, you can just put a colon. Yeah, either one. You can put both. Cool. Yeah, parentheses imply, so this implies, if either you leave this out or you leave these empty, it implies you are extending the Python class object. So it's like inheriting general properties, but you don't have to explicitly specify it. Okay. So object is, well, we can look up what an object is. Oh. Oh, it's just object lowercase. That's no fun. Doesn't take any parameter. Yeah, I don't think it does anything. Yeah, not really anything interesting. Or you can, has a quality defined less than, okay, so it does some things. Anyways, there you go. Yeah, so I guess it would extend object lowercase like that. Okay. Okay, what else needs to go in a function definition? Like, how do I make a new instance of a class? So if I wanted to say like x equals linked list, and then I wanted to initialize it in some way, how would I tell Python like what to do, like what to do in order to make a new list, linked list object? It's a special function. Oh, sorry.
You have to define the initial function. It's like underscore init and then underscore.
Yeah, and then what are the arguments? Does anyone remember?
I don't.
Okay. So
Self, right?
Yeah, exactly. Yeah, self, and then whatever other arguments you want. Okay. So, okay, so there might be something there. Now to fill this in, we have to start thinking about what is a linked list. Does anyone know or remember?
It's like a series of essentially, you basically just create an objects that can be linked together that like refer to each other.
Yeah, in a specific sequence. So it's like you have each element is going to have a value and going to tell you how to get to the next thing, or that's the last thing in the sequence. So like, if you've heard of like research on computing the like gazillionth digit of pi, well, anyways, that's a thing people do well, it's very important, no doubt. Anyways, okay. It's a worthy pursuit. Okay, something people do at least. anyways, to like work with numbers with millions or billions of digits, there's no like Python or really any language object that like comes naturally with the language that will let you work with numbers that big or that precise. And so you could use a linked list where each digit is a element of a linked list, and then the full sequence would be like, well, a linked list with the digits connected to each other. Okay, so like fancy math libraries sometimes use linked lists to represent numbers. Okay. Okay, so each item is going to need a value. Let's just call it value. That's really all we need to initialize a new linked list. And so we could set the value, self.value, to however we initialize it. And then we also need a way to point to the next item in the sequence, and we can initialize it to none. It seems like a reasonable default. We could initialize it some other way, but okay. And well, that's really all we need to make a linked list. So we could have x equals linked, or x1 equals linked list of, let's see, 0. x2 equals linked list of 1. x3 equals linked list of 2. And then we could say x1 dot next equals x2, and then x2 dot next equals x3. And now x1, well, it's just a linked list object, but its value is 0. And then the next value is 1. And then the next value is 2. But then the next value, there is none, so it's going to give an error. Okay. Cool. So that's a linked list. That's not too bad. But we could also define some. Okay, any questions about that? No.
What's the benefit again? Like
why would we do
go
this?
To all this trouble? Yeah.
Well, first, I mean, the one example I had given was like, if you wanted to store a sequence that didn't fit in memory, or that didn't fit within any of the like standard Python data types, this allows you just to manipulate one part of that sequence at a time. So you don't need to store the full thing in memory.
Yeah, that makes sense. Okay.
Okay, we'll leave it there then. Okay, let's see. Yeah, maybe, well, okay, I think 2 other functions would be useful to convert to and from just for debugging, to and from like a standard Python list, just so you can like, work with these more easily. So let's make a function to like do this stuff automatically so that we don't have to do it every time. So we could say, we could use a list comprehension. Items equals linked list of I for I in X. So that'll give us like a linked list object for each of the items. And then if length of X, equals 0, then we just do nothing. otherwise, let's see, for I, which is the index, an item in enumerate items. Yeah, so I'll explain this in a sec. Okay, and then return items of 0. Okay, so what's happening here is if we pass in an empty sequence, we're just going to get none back. And then otherwise, for each element in X, now we have a linked list of length 1 with just that element. But then if we want to connect them all together, so we can set the next property of each item of this list here to be whatever the next item in the sequence is. And we just chunk through each item in turn. And this little snippet here goes until 1 before the end. And then this here refers to like the next item after I in the sequence. And then we're going to return the very first elements, like the very first element, the very first item, which should have all the nexts properly set. So let's see if this works. X equals list linker, and then we could just make a simple sequence, 1, 2, 3, 4, 5. And we could say like X dot value, that's 1. X dot next dot value should be 2. Great. Next value should be 3. That should be 4. That should be 5. And then this should error. Great. Okay. Does that make sense? Okay. And then another function I thought might be useful is to like convert a linked list back to a list, so that you could, also for debugging. So you could do something like store the value of yourself, and then say like, well, next item dot next is not none. Next item equals next item dot next. Oh gosh, what did I do? And then X dot append next item dot value. And we can return X. Okay. So then X dot as list will give us back the list. Okay. Okay. So I think so I'll paste these into Gitter so that you all have them. Oops. Oh, that's not nice. Let's see. Delete that. Let's see if this works. How do I just send it? No, it's, oh, weird. Command return sends it. That's weird. There you go. Enter and shift enter did not send it. That's what I was expecting. Okay, and I'll paste in that. Wonderful. Okay. Okay. So what do you think? You want to try this? Try writing a quick sort algorithm for linked lists. So like if I give you, so how it should work is if I give you like quick sort of list linker of like 5, 4, 3, 2, 1, then you should get back a linked list with the values of each element 1, 2, 3, 4, 5. All right. Do you feel like you have enough information to attempt this, or do you need more guidance? What do you think?
We can give it a try,
All right.
maybe.
Okay. Well, I mean, you can always try, right? We could all fail. Okay. So here's what I propose. I'm gonna. I don't know. Do you think bigger groups are more helpful or smaller groups are better? Who would like bigger groups? Okay. Who would like smaller groups? Well, I mean, do you want to just do it as an entire class, or like how big? Should I just do 2 breakout rooms? 2 breakout rooms? Okay. And then you can compete against each other. It's like, yeah. Okay. That sounds nice to me. Okay. How about this? Why don't we use Gitter to, like, if you want to get my attention and you want me to drop into your room, then you tell me in Gitter. And you can also use Gitter to share code snippets and communicate with each other. We'll try this, and maybe in like 15 minutes, we'll come back. That's probably not going to be enough time for everyone to solve this, but we'll talk a little bit about, what's going well, what's not going well. And then, on Friday, we'll see if this is still useful and either pick it up again or move on to something else. Okay. Lovely. Okay, so I'm going to stop sharing my screen and I will break you into breakout rooms. All right, everyone. So how did that go?
It was a little bit short.
A little bit short. Did anyone make any progress, or was it just too short to even get oriented?
We figured out how to use copy and paste.
Like into collaboratory?
Yeah.
Okay, well, that's some progress. Congratulations.
We talked through the next steps.
Okay. Do you want to, do you or anyone else want to like share kind of insights or thoughts or like tricks you think you'll need to solve or questions raised, show-stopping issues?
We were struggling with creating like a storage container for the lower and high values. We were trying to come up with a way to create an empty linked list, but weren't really sure if it was possible to do that or how you would go about doing that.
Does anyone have any ideas for that? So, okay. Well, one idea off the top of my head, if you wanted an empty linked list, is that you could just create a linked list whose value is none. And then you could have that kind of as a temporary or like a placeholder. And you can always update a particular item's value by assigning like item.value equals some new thing. And similarly, you can kind of hook it into a list by setting, the previous item's next attribute to the item that you want to add in, and then that item's next attribute to the item that used to be linked to by the previous item. so that you can kind of, I don't know if that hand motion made sense there, but yeah, kind of tracing out a upside down omega thing. Yeah, or ohm symbol, yeah. Let's see a demo. So oops, I need to share my screen. Okay. There we go. So let's say X equals list linker. And then if Y is some new list, then I could say like temp equals, let's see. Well, first, so I want the last item of Y. Let's say I want to insert after the 4 and before the 3. So now I can say like X dot next. Well, first I'll try to save this 3 item. So second part of X equals X dot next dot next. So second part of X dot value is 3. Okay, great. And then we could say X dot next equals Y. And then Y dot next dot, so 10, 9, 8, 7 dot next equals second part of X. Oops. There are too many X's there. Yes, I do. Okay. And then I could say X dot as list. And now these items are inserted. Does that make sense? So it's like I took these items, which was X dot next dot next. So this item dot next is this item, dot next is this item. And that points to the rest of this list. And I saved it here. And now I'm going to make this 4 go to this 10. So that was like that part of the hand motion. And then this 7 has to be hooked back into this 3, which is the second part of X. So that was the upwards part of that hand motion. And then the second part of X is just unchanged. Okay. We'll meditate on that. Okay. All right, so I think things that you might want to think about. Maybe we'll take some more time on Friday to like think through this after you've had some time to think about it offline. So, other things to think about would be like, if you wanted to select an item at random, how are you going to go through the linked list and keep track of like how many items there are, and then select one of those at random? So that's a thing you'll need to solve. And then second, if you want to divide the linked list into 2 parts, how do you do that? So that's a mystery to solve. And then third, if you want to stitch 2 linked lists together, how are you going to do that? And then finally, you could encounter a situation where you need to create or work with an empty list. So like if you have a list of length 1 and you want to sort it, then like either the A or the B part, like less than the pivot item or greater than the pivot item, is going to have a length of 0. And so you need a way to deal with that. And that could have multiple parts to dealing with it. Okay, so think more about that. And then maybe we'll spend some more time on Friday trying this. I think it's a worthwhile exercise to go through. And then I also recognize that Friday is our grad recruitment day. So for the graduate students, I realize not everyone is going to be able to make it to class, and there's no need to let me know if you can't make it. I'll just record the lecture like I always do, and then attend if you're able to, and if not, you will be missed, and we'll see you in the next class. Please also take a look at assignment 3. Tentatively, I'm going to set a due date for that for a week from Friday. It's a bit hairy to go through the code, but it's worth spending some time to really understand it. It's going to help build character through suffering and pain. And also, like, in seriousness though, it'll give you some good practice, like really digging into complicated code, which is the actual point of the assignment. But bring questions on Friday and or Monday, and we'll go from there. And yeah, and have a great day, and I'll see you on Friday or Monday.